What is isostatic adjustment, and how does it affect sea level rise? Imagine the Earth as a giant sponge that slowly responds to changes on its surface. When huge ice sheets grow or melt, they cause the land to move up or down over thousands of years. That's what isostatic adjustment is all about. It's the process where the Earth's crust reacts to weight changes from ice. When ice builds up in polar regions, it presses down on the crust, making it sink. When the ice melts, the crust begins to rise back up, a process called glacial isostatic adjustment or isostatic rebound. This movement happens very slowly, often taking thousands of years because the Earth's mantle underneath acts like a very slow-flowing fluid. In polar areas, where massive ice sheets have existed for thousands of years, this process is especially important. When ice melts, the land beneath it starts to lift. This uplift can actually reduce the local sea level because the land is rising faster than the ocean is rising. But on the other hand, the edges of the former ice sheets, called forebulges, can sink gradually as the crust readjusts. This sinking causes the sea level to appear higher in those regions, which can lead to more flooding and erosion. This process doesn't just affect local areas. It influences global sea level rise too. When ice melts, it adds water to the oceans, making sea levels go up worldwide. But because the Earth's crust is adjusting, some places might see less of a rise or even a temporary fall in sea level. The redistribution of mass from melting ice also changes Earth's gravity and shape, which affects how water spreads across the oceans. That means sea level rise isn't the same everywhere. Near the poles, the land rising can offset some of the sea level increase, while in other regions, the land sinking can make sea levels seem higher. This adjustment impacts coastal ecosystems in polar regions. As the land lifts, new areas may become exposed, creating new habitats. But in regions where the land sinks, flooding can become more frequent, threatening plants, animals, and human communities. Since this process continues even thousands of years after the last ice age, it's an ongoing factor to consider when studying sea level rise and planning for environmental conservation. Understanding isostatic adjustment helps scientists better predict how sea levels will change in the future. It shows us that sea level rise isn't just about melting ice. It's also about how the Earth itself responds to those changes. This knowledge is vital for protecting polar ecosystems and managing the environmental challenges that come with a changing climate.